Hello, welcome back to ReddyControls. Most people don't struggle to build a add-on instruction set, but they struggle with how to actually use them. They wonder how to open an add-on instruction set, how the parameters are being passed, and what is a InI input-output parameter. If you look at the screen here, you ran into scenarios where you open the AOI logic and everything is grayed out, and you're wondering how this AOI actually works. This video will build a simple AOI that filters bouncy input and also counts the clean signal from the bouncy input. And you'll also learn how to trace AOIs in Studio Python. I ran into this issue while I was testing a limit switch on a conveyor, which has a lift which goes up and down. The signal was bouncing and the counter would count 2 to 3 times. To fix that, I created a simple AOI which filters out the noise. In this video, we're going to show you how to build that AOI from scratch. This AOI called Debounce, RC_Debounce, takes a raw input signal and generates a debounce signal, and it takes a preset of 2000 milliseconds, and you also have a in-out pulse counter. So we'll go ahead and create this from the scratch. Before defining the AOI, let's understand what a AOI parameter is and what are local tags. AOI parameters are like the values that you pass in and out of a add-on instruction that's used in the main logic. They work just like inputs and outputs, like for a timer or a counter up. They interface between the custom instruction and rest of the PLC logic. For our debounce AOI, we use a input signal which is of type input. That means it's going into the AOI, and that could be a limit switch or a push button. And then we have a debounce time in milliseconds. That's the input. It's a type of DINT, and it's the time for how much the signal should be stable before we call it a good signal. And then the output, we use a parameter called debounce signal. That's output direction BOOL. And then we have a in-out parameter, which is a pulse counter, which increments every time a clean signal is processed. And then we have something called local tags. These are internal to the AOI. They are not visible to outside. They're only used inside the AOI logic, like temporary variables or internal timers. We use 2 temporary local tags, which is a debounce time, which is an actual timer that we use for filtering, and then we have a rising edge for pulse count. So now let's go back into the PLC and develop this AOI. This is a simpler AOI. I have made one more video on my channel. The link should show up on the top. Please look at that. That will give you introduction of add-on instruction sets, inputs and outputs to the add-on instruction and the in-out parameters too. So add-on instruction set, how do we define it? We can define add-on instruction sets when you are offline. Right now I'm online with the PLC, so I will go offline, and you could define add-on instruction sets under assets. So if you go to the IO tree, go down assets, you could right click on add-on instructions, right click new add-on instruction, and if you already have a existing add-on instruction, you could import that too. We'll go ahead and create an add-on instruction, and here just any name, we just call it ready, say RC debounce _2, right? And you could give a definition and description of what it is, and revision note, who is the author, and see this open logic routine and open definition. Once you click OK, the window opens up, which looks like this. And in this window, you have the general properties, and then in the parameters is where we'll go ahead and create the parameters we talked about, right? So the parameters we talked were a input signal. So we'll go ahead and type input _ signal, and it's a direction or usage is input to the AOI, and we want it to be a BOOL. And you could come down here and you could select it as a required, then it will be, you must enter that. So since we need the input signal, we'll say required. I'll skip the descriptions, but you could, for the time's sake, I'm skipping the descriptions, but you could write the descriptions over there. Sorry, what's happening? Okay, so we have input signal, and then we have a debounce time in milliseconds, like how long do you want the signal to be active before you say it's a good signal. That's a debounce. And debounce signal, it's again an input and it's a DINT, and we also say we require it as a parameter to enter. And then we have a debounced signal, which is the output of this AOI. So we call this as an output parameter, and again it's a bool. And then we going to create something called a pulse counter, which acts as both input and output to the AOI. That means we can pass it into the AOI and AOI can update it, and then we can use it somewhere else outside of the logic. So that's called passed by reference, meaning changes inside the AOI are visible to the outside of the AOI. So those are all the parameters we defined, and now we go into the local tags and create two local tags which we talked about. One is a debounce timer, which is of timer instruction, and then we have a rising edge, which is of bool data type. Okay, so we say apply, and then you'll get the data type size, right? So what we created is we created an add-on instruction, and for that add-on instruction it immediately created a data type of add-on instruction, and you could see that in add-on instruction here. See, it created a package of add-on defined data type called RC Debounce_2. So once we say okay here, you could either click logic, which will open up the logic, or you just say okay, and you can click here, which comes back here. So now we are in the definition page of the logic, right? So we are in the definition phase of Debounce2. So I'll go ahead to the previous definitions of the debound. I'll just copy paste this to save time. So we go ahead and Control V. So since our variable names are different, let's not copy paste to Control. Okay. So first thing we want to do is we want to insert a move So what we want to do is we want to take the debounce time, which is a parameter coming from the logic into the AOI. We want to move it into the timer we created. The timer we created was a, okay, let's go back to the parameters and local tags again. Okay. Oops. Okay. So we want to move that into the debounce timer. So we created a debounce_timer, right? Debounce_timer dot preset. So what we did here is when we define the RC Debounce_2, we tell the AOI, hey, wait half a 500 milliseconds before you may count the signal as good. That's all we're trying to do, just pass that data into here. And then once we have the data, we're going to look at the signal, which is, again, we insert a line here. So our signal coming in is input signal, and we go ahead and insert a T on timer instruction, and we call it a debounce timer. This is a local timer. This is the definition, right? Debounce timer, and the preset would be whatever we move from outside. Okay, and if the input is on, and if the input does not change status and it's still on for whatever the debounce time is, and once the debounce timer is done, we want to pass to the output signal, which is called as debounced, I think debounce signal. Okay, and every time we have a debounce timer done, we will use a one shot that we created, rising edge, and we want to insert, oh sorry, escape. We want to insert add instruction. We want to take the pulse counter and add one to it and move it back So we're just incrementing the pulse counter. Okay. So that's our definition of the AOI. Okay. That's the definition of AOI. So now we are done with the definition of the AOI. We save it and try to define an instance of this AOI. Now I have downloaded that program after defining the AOI. Now we'll go back into the main routine, and this is the older AOI that I use, so I will delete all that. So what we want to do here now is we go ahead and insert a new rung, and if you go on to this add-on instruction group, see all the AOI definitions show up as an instruction. So this is the RC Debounce, so I click that. Now it assembled an instance of it, and we need to create a tag that we need to give it a tag for, let's call it sensor 1, right? And we go ahead and right click, create new, and that tag will automatically be of the type RC Debounce2. So create. So now if I go back and monitor that sensor just to show you how it looks like, it has a enable in, enable out, which are by default, and then it has a input signal, it has a debounce time underscore ms, and it has a debounce signal. So these are the parameters. So it's showing all the parameters, but it's not showing the internal tags, which is the timer and the rising edge, right? So we'll go ahead and say we want to give it a signal. So instead of giving a signal, input signal, I'll just create a limit switch 1, right? So we create new limit switch 1, and it's of Boolean. And we want a debounce time of 250, say 2 seconds, so 1 second. That's about 1000 milliseconds. And then we want to create a limit switch pulse. Okay. And we just call it a DINT. Okay. It makes sense once I show you how we're going to use this one. So what we're going to do is we go ahead and install one more rung to rung 0. So I have a Compact Logics PLC which has local embedded IO. So I'm going to just map a input local input 1.0, and I just call it sensor 1. Okay. I'm sorry, I just call it limit switch 1. Okay. So what I did now is I'm taking the input 0 on my input card, since I don't have a sensor, I'm just creating a tag called limit switch and passing that limit switch into this AOI, right? And then this AOI will take that limit switch, add a debounce of 1000 milliseconds, and create a signal, the out signal, right? So if we right click, if you want to see the logic, you right click, open instruction logic, and you could see that's what happens. So whatever parameter going in will come in, map to that input signal, and once this timer reaches 1000 milliseconds, it's done. Then it will give outside, it will give a debounce signal to out, right? So to make it easier, let me show you this way. We will create a sensor 1, right? We know sensor 1 dot input signal, which is nothing but this limit switch going into here. I want to show you that. And then we also want to see sensor 1 dot debounce signal. Okay. And we just insert NOP. Okay. So now when I push the start button, you could see the input switch made 1, and after 1 second the debounce signal is coming on, right? See, when I push the button, input signal comes on, but the debounce signal will come on after 1 second. I'm sorry, 1 second and then comes on. So that's how this AOI works. You could do the same thing. You could open instruction logic here. When you push the button, the input signal comes in, timer done, and debounce signal comes on, and you could see the pulse counter counted 5 times, right? So now I know, since pulse counter is a input output parameter, I could use it outside the logic to do something, right? If I want to say, if the pulse counter, what was that called? It's called sensor 1 dot limit switch pulsed is the name of the tag. So we come back and say if limit switch pulsed is greater than 4, do some action. You can do whatever action you want. So that's how you use the in-out parameter. So if you right click, if you click that, you get the view parameters, and it says pulse counter, which is in-out. It's showing you the limit switch pulsed as a configure tag, and that limit switch pulsed is whatever inside. If you open the instruction logic, this pulse counter is being fed back into this limit switch pulse. That way I can just use limit switch pulsed as a tag outside in the logic. Okay, let's see if we covered everything we need to cover in this one. Yeah, so one of the question is like, how do you monitor it? We already showed it. Right click, open instruction logic, make sure the data context is correct. If you select the definition, everything will be grayed out. We want to select the instance of it, sensor 1. That's how you do it. And then we already looked at the in-out parameter. That means when AOI changes them, the result is reflected immediately in your program. In this case, our pulse counter increments every time the signal is filtered. So in this video, you learned how we define AOI parameters, what are the local tags and how they work. And we also looked at how in-out parameter works. And we also looked at how to trace the AOI logic live inside Studio 5000. You can download this AOI, try it on your project, like, comment, and subscribe if this helped you, and check out my deep dive video on how to use timers. The link will show up below. Subscribe for more ReddyControls. See you in the next video.